started the recording, so if there's anyone that doesn't want to be recorded, unfortunately, you have to leave the meeting. So with that said, today's topic is versioning of IMF types. We're not going to show too much fancy, but we're going to walk you through the strategy. And today, Bård is the lucky winner that's going to present this for us. So go ahead, Bård. I think you're muted, Bård.
As long as that's the biggest issue. Can you hear me now?
Yes.
Excellent. All right, let me just restart the presentation here, and I'll share my screen. All right, so let's see, share. Can you see my screen now? Evolution of IMF types.
Yes.
Excellent. All right, so now DISC show and tell next week. So looking forward to it. But that also means that we would like to avoid doing any big changes. So we have all of this great feedback already, and we're working on it. But this time around, instead of showing that we've done things without feedback and push changes late the minutes before show and tell, we thought this was a great opportunity to talk about the way ahead. How do we intend to basically manage IMF types as we go along, as there become more and more of them, and we need to ensure quality. So how does we envision that these IMF types will evolve? And in that regard, we will talk about 3 types of evolution, and it's updating, replacing, and refining. And to understand those, we first need to take a detour into an approval process, and I'm kind of jumping ahead a bit here because the approval process is something that will also come into play and be discussed when we move further into autumn. But in this case, we just need to talk about it because we have on our left-hand side we have draft, and then on our right-hand side now we have suggestions and further approved and rejected. And to the left here of this arrow or line as it drew, we have things that are changeable. And then on the other side, on the right-hand side, we have things that are unchangeable. And that separation is kind of important to how we can update, how we allow our IMF types to be updated and evolve. So when we talk about updating, we will only allow something to be updated. That means directly changed. And I'll show what I mean by that further ahead. In this draft stage, when things are changeable, we will replace, when we are in the unchangeable era, and then finally we will be able to refine throughout the whole process. Okay, so now we'll start with the updating phase, and we'll move into replacing, what that means, and then we'll talk about refinement. And replacing and refinement are 2 completely different things, as we will see. But we will still like to discuss these strategies with you. Okay, so when we talk about updating, and remember now, this is something that we can do in the draft phase. You have submitted something, you are working on something, and in this case here, we have a IMF type. It's the quantum flux generator from a previous demo, or and that has a description, which in this case is the quantum flux generator is a speculative concept lacking scientific evidence. All right, and it's also have an ID, where you see the end of the GUID on top there. When we are in this draft updating phase, you are allowed to change. You are allowed to change the description or any other component of your IMF block, terminal, or attribute. That change means that it will just overwrite the existing information. The ID will remain the same, but the definition will now be different. This is a change. This is an update you can make. You can only do it in the draft state. I'm kind of pointing that out or emphasizing that. Okay, let's take another example. We have here the quantum flux generator with one of its properties, the maximum design pressure in barge. And underneath it, we see the definition of pressure as it's given in PCA staging and staging 3 environment. But what if we would like to kind of change this? If we would like to change now this maximum design pressure attribute and say that, well, the definition is now what we find in the production environment of ISO 15096. This is now, again, a change. We're in the draft state. We're just updating. We've changed the exact sorry, I clicked my screen there. We have kept the ID of the attribute, but we've changed the description. And that means that this change also just happens to arise wherever this attribute is used, which is in the quantum flux generator block, which still have the same ID. So when we are in draft status, we can just update and change things. Right. Why did ISO go through this so common thing so thoroughly? Because things change when we get through replacing. Now we are no longer able to just update things. We have to replace them, because that information that we've had previously, we should maintain. We should keep it for historical records, because somebody can be using it. So we need to be more careful. We cannot override existing information any longer. All right. So here we're back to the example. We have this flux generator, and it's using this attribute 5159. Okay, that attribute, that's just used in this block. It's defined somewhere else. So it's defined below. And if I now want to change, or not change, not replace, sorry, if I want to change this attribute during the unchangeable state, then we need to replace. And by replaces, we actually mean, we haven't decided yet on the predicate, we just call it replaces for now, but that we create an entirely new attribute. It has a new ID, and there's a new triple in our graph. There is a relationship in the graph that links these two attributes, these two concepts. And this new attribute that we now created, that has no impact on the quantum flux generator block at all. That will still reference the old attribute concept, so that people can still use the old version of the quantum flux generator block. This is important. So now when we would like to kind of update our quantum flux generator, well, we have to replace that as well. And the change that we've made is that we've changed an ID number within the block. And the block itself has been given a new ID, and it replaces the old one. This allows us now to traverse the graph and actually discover the history of things. How has this item or this concept or this IMF type evolved through time? Yes, of course, this is when something is not accurate, if something is wrong, and we need to kind of fix it. If things are correct and you just would like to add a new block, for instance, that you can create a new thing. But in some cases, we would also like to say something about how blocks or things are related to each other. And we now talk about refining. It basically means that if we have a block and we would like to say something more about that, we have a parent and then a child, and the child should inherit basically all the properties of the parent and be a more refined version of this. Then we're talking about refinement. And let's take an example of that as well. So here we have the quantum flux generator, and it has this one property that we've set up. And then we would like to create a new attribute, a new block that is a refinement, a specialization of that original block. And what that does is that it is given a new property. That's the refinement. I have the property in my parent, and I need the property of my parent, and then I add something more. That's the key here. And in this case, we say that I've said that the original property is covered by parent. And I'll come back to that when we dig into the details a bit more when we look at the shackle. But we have one other case. So in this case, we've just added an attribute. We've said that we need something more. It's a specialization. And there's another specialization we can do. We can say, well, in this case, in the previous case, these attributes are optional. The green attribute down here is required. So it's the same attribute, but there's a stricter reinforcement than of the parent. That says that the original parent said that, well, we need pressure, or you can supply us with pressure for this block. And in the next, perhaps you say that, okay, in addition to pressure, we would like temperature. And in the final block, we said, well, you might submit temperature, but we need pressure. That should be included. So that's a must. That's a requirement. Okay, and so how does this work? Well, we basically use the shackle shapes for this, and now we're into the nitty-gritty details of the refinement. But we say that if you have an individual of this quantum flux generator with the required property, you need to first be validated against your own shackle shape, and then you need to be validated against your parent's shackle shape and the shackle shape above. So you need to fulfill all those shapes. And this approach, it's basically done with subclassing the shapes themselves. So you see here that we have a subclass of, and we have the subclass of the parent and the subclass of the parent again. And here we have that the minimum count should be 1. So this is a required feature here. And then it's 0 and 1 up here, which means that is an optional attribute. Doing this, the reason why we can do this in draft mode now, because we can actually change the parent, and then we can say that, okay, then there's a new requirement that all the children need to fulfill. Yes. So this is how we envision refinement. Which means that by this approach, we can actually create like hierarchies of refinements where you, to a different degree of can say these attributes are required in my case. And we can use this for saying that at an early stage, I have a pump. At a later stage, I know that is a centrifugal pump, well, means that we can use the specialization of feature of IMF, which this should be in accordance with. And finally, when we need to check these IMF types, not the types, but the individuals, whether or not they belong to a certain type, then all of these required attributes come into play. Those are important there. They are not just guidelines to what attributes you can add to your individuals, but actually requirements to fulfill these different type descriptions. Yes, that's it for me today. Any questions? Let's see, I cannot see.
A lot of good thinking, at least. Yeah.
Thank you.
I agree, Arne.
If I just stop sharing, I can see if there's any
There's
questions. Mihaly, you have a question?
Yes, hello. It's a very good and exciting area you describe here, Board. One specific aspect I wonder about using Shekel shapes. As you mentioned earlier, that there's a difference between when you have a all open world approach to describing your needs for the information, and the Shekel closed world approach, which is a validation of based on the Shekel shape schema. Have you considered the need that through the life cycle of the object, which represents a physical thing like an equipment or a system, you can have different requirements in which point of time, what kind of information you need? So it means that in an early stage in the project phase for a main equipment, you can have less information than later in the detailed engineering phase.
Mm.
How can we manage it with that system?
Well, to me at least, I think like that's what this specialization or refinement is supposed to mean. Well, it means that you have to change between you have to, as your level of detail increases, you need to find more refined types. But that should be supported in the IMF as a specialization of, and then you can point to these refined types where you have, say that you have added attributes entirely to get more information, or and so you can start out with a very broad or a very kind of non-informative block, for instance, with very few attributes, and then you can say that this was what I had in design, and now I moved forward into detailed engineering, and I need more attributes, and I can choose another type that is a refinement of this type. So now you should cover the shackle of both of these two types. And then you can say further down that, okay, I have these requirements for this pump or equipment, and then I actually have to validate against these required attributes. They're no longer only optional, they are actually required. So now you have to validate against and like the chain of shackle shapes. No.
Yeah, it makes sense. Thanks.
Does that answer
sure.
your question? Yeah. Mm. And on the individual level, like this is on the type level. So on the individual level, there are already this specialization of predicate in the IMF toolbox.
Yeah, I see the point. There is one aspect I see it could be complicated, because naturally when you build up a class hierarchy with specialized classes, subclasses, it will result that the different specializations have different properties, right? So the above level, you have the common properties, but when you have two different subclasses, it means that they have some differences, probably added properties. But in that case, we need to have a new dimension when you see the life cycle aspect as part of the hierarchy. And it will complicate a little bit that hierarchy, because it will be two aspects. But it would be nice to see the details about that.
Okay, yeah, that's a good input.
So if you look in the very easy example, and your top level class is the physical object, and all the physical objects, for example, have a common property like the weight. And when you say that I have a class electrical artifacts and process artifacts, they have different characteristics, different properties. But within that structure, you need to add the life cycle aspect that about the electrical artifact in the early stage, in the project phase, I have only those properties required. But in the detailed engineering, I have additional properties required. And in the commissioning, I have extra properties required. So it will make a more complex hierarchy. I'm not stating it's impossible, but
yeah, no, I think you're absolutely correct. And one of the key things that we have to figure out is what part of this information should be on the type level and what part should be in the information model that you instantiate, right? Because when you get these requirements, you have actual requirements and they need to be met at perhaps the type level so that you can check that your instances are correct.
Yeah.
But where all of these connections will reside is, yeah, it's not, I don't think everything there is decided yet. That's going to be interesting to figure out.
Yeah. Okay. Thank you, Board.
Any other questions? Ross?
Not a question, just info. We are posting these recordings on our YouTube channel. So if you want to look at this again and again and again, or if you want to go back and look at some previous ones, you can find them on the PCA YouTube channel. I will also add the descriptions also, so it's easier to find the ones you are interested in. That's all.
Awesome. All right. If there's no more question, I think we can wrap this up.
Yep. All right.
Thank you very much.
Thank you so much, Board.
Thanks a lot.
It was great. And
Welcome.
have a great weekend.
Have a nice weekend, everybody.
Thanks, same to you. Bye.
Good weekend.
Bye-bye.
Bye.